This video, we are going to take a look at how to interpret the analysis that we found after sensitivity analysis in Excel solver. So let's check out select and binding constraints first. So what select is, it is the difference between the left hand and right hand sides of a constraint when the optimal solution is substituted for the variable. So at the optimal solution, if you create the sensitivity report in Excel, the constraint cells or constraint tables, they're going to identify whether there is a slack in a constraint or not, and if there is a slack in that constraint, then that constraint is going to be called non-binding. Okay, so a constraint is binding if the slack is 0, right? If the slack is 0, then the constraint is binding. If there is a positive or negative slack in that constraint, then the constraint is non-binding. Why these are important, I will explain in a minute. So for example, here the amount of resource used, that's our constraint, less than or equal to the amount available, right? So the amount of used is equal to amount of resource unused, and that's equal to the total amount available. So therefore the slack is the amount of resource unused here, right, on the left hand side, and can be calculated by the amount available minus the amount of resource used. Okay, what do I really talk about here is the example. So for the constraint cell, so for the fabrication, finishing hours, and the market mixture, right? So the final values are given here. Here the shuttle price is equal to 0 for this constraint. The right hand side of the constraint is 84. What you see here is that this left hand side is not equal to the right hand side of this constraint, therefore there is a slack in the first one, right? The slack here is 84 minus 6.375. Okay, on the other hand, in the finishing hours constraint, so we do have a final value, the left hand side value of 21, and the right hand side value is 21 as well. Therefore here the slack here is 21 minus 21 is equal to 0. Therefore the fabrication hours constraint is non-binding because there is a positive slack here, but finishing hours constraint is binding because the slack for that constraint is basically 0. Okay, all right. Okay, so let's check out more concepts. The first concept is a reduced cost constraint concept. The reduced cost, we do have a reduced cost component for each decision variables, not really constraints, but the decision variables. As you can see, the reduced costs are 0 for Jordanelle and Cross models. So reduced costs are basically how much the objective function coefficient needs to change for a variable to become positive in the optimal solution. Well, guess what? All these two variables are positive, so therefore the reduced costs are 0 because there is no variable here that are equal to 0, so therefore we cannot really talk about the reduced cost for these variables. But if there were some extra decision variables, let's say like x, another model, and then the final value is 0 and the reduced cost is, let's say, 20, and then let's assume that its objective function coefficient or the net profit value is, let's say, 30. What this means is that at the optimal solution, the model X is not being produced, right? That's why we got 0 for that. And then the reduced cost is 20, meaning that if the objective function coefficient 30 right now is not really a profitable option for this model X. So therefore, if the objective function coefficient or the net profit value for this model X would be like 30 plus 20, that makes 50, right? If the net profit for model X becomes 50, then the model would consider producing model X, okay? So basically the reduced cost, if you go back to the definition, it's how much the objective function coefficient needs to change for a variable to become positive in the optimal solution. So the objective function coefficient or the profit for this model X should be $30 more so that the model can consider producing Model X. Okay, otherwise we don't see Model X in the optimal solution. Allowable increase and allowable decrease, those are the ranges that that specify how much an individual objective function coefficient can change before the optimal values of the decision variables will change. Well, let's check them out. So here it says, okay, allowable increase and allowable decrease values for each product. Okay, for Jordan, this is practically infinity, right? It's practically infinity, positive infinity. It says the allowable increase is infinity and allowable decrease is 6.666. So based on the definition, we can say that the objective function coefficient can be increased all the way up to infinity, and it can be decreased by only 6.6 if the objective function coefficient is still in this range. Then this final value of this product is not going to change. So if you make this, for example, 50 to, let's say, 55, the optimal solution is going to stay the same. Okay. If you make this to 1000, again, this value is going to be the same. Okay, it's not going to change. If you would like to give it a try, you just need to go back and then go to your model. So here for 50, you make it 1000. And you just resolve the problem, right? Solve where you don't change anything, just click resolve. As you can see, these values 5.25 and 10.5, those have not changed at all. Okay, I'm not going to keep the solution. Okay, I will just leave as it is, and I will make this profit as 50. Well, again, you don't need to solve an extra optimization problem to be able to say that. Excel solver already gives you these reports. Okay, so but for example, for a allowable decrease, it is limited here. So if you make this, let's say 45, okay, decrease it by only 5, it is within a allowable decrease. You can still decrease it by 5. It says that this 5.25 is not going to change. Well, let's do that. Let's make this 45. Let's see whether this 525 is going to change at the optimal solution or not. Click solve. As you can see, it did not change. Remember, the total profit changed because we changed the profit per Jordan L, but the total amount we produced at the optimal solution for Jordan L has not changed. And then again, we would have known this if we looked at the sensitivity report only, right? So it's right there. Very useful information. But guess what? If you cross these ranges, for example, a global decrease is 6.6 something. So let's assume that we decrease this to 40. Well, this value is going to change. Okay. Let's try it out and validate it. Let's make this 40. If the net profit for the journal product goes down to $40 per product, this value is going to change completely. It's going to go down to 0. All we produce is the crest. Okay. I'm not going to keep this change, so I'll hit cancel. I will make this original file. So these values are very useful from the managerial perspective. These values are actually the key. So it basically gives you what happens for the worst case and for the best case. Okay. There's one other. Okay, Shuttle Price is the last one that I would like to describe to you. Oh, before that, there is also a allowable decrease and allowable increases on the right-hand side of the constraints. So therefore, these are the same concepts on the constraints right-hand side. So for example, this is again infinity practically. It says that, for example, finishing hours, a allowable increase on this value can be 8.2, a allowable decrease on this one can be 21. So if anything happens within these ranges, we still keep these values. Nothing is going to happen, right? But if you cross these ranges, you have to solve this problem one more time with the changes. Okay, so the shuttle price is also another important concept. So it says how much the value of the objective function will change as the right-hand side of a constraint is increased by 1. Well, this is really critical because what you see here is a really key value, a key information to address a managerial question. For example, it says that the shuttle price here for the specific constraint is 0. For the fabrication hours constraint, you see that this is non-binding constraint, right? And we know that because left hand side is strictly less than right hand side, we still have select available in this constraint. Well, if you see a positive select in this constraints, then the shuttle price is always going to be 0. Remember the shuttle price, the definition is how much improvement you can get in the objective function, meaning the total profit, by increasing the right hand side value of this constraint by 1, right? If you make it 84 to 85, what happens? Okay, how much more profit you get at the optimal solution? That's the definition of the shuttle price. It says 0. Well, is that the case? Well, as you can see in this current format, which is 84, right, we are not even using the complete amount of resources that we have. We are only using 60 point something, right? It's not even close to 84. Well, if we don't care if you increase this to 84, from 84 to 85, the right hand side value, the total availability, right? We don't care. Simply, it's not going to help us improve this objective function value. Well, that's the logic behind it. On the other hand, the second constraint is binding, right? Because the left-hand side value is equal to the right-hand side value here, and then therefore there is no select, and then shuttle price is positive, which is 45. Well, this implies the fact that, okay, if you increase this to 22, then the total objective function value, which is 945, well, the new objective function value is going to be 945 plus 1 times 45, which is $990, right? Well, is it within the range, right? So yes, it is within the range because the allowable increase is 8.2, so one increase is within the range, so this new value is going to be 990. Well, if you'd like to try it out and validate it in Excel, you can do that. What we did is we increased the number 21 to 22. Sorry, this is the cell formula. I should not touch that, so I should increase it right here. Okay, and then let's see. Please watch this 945. It should become 990. There you go. It became 990 at the optimal solution. Well, let's make it 921. So again, if you know this information, you don't need to resolve this objective optimization problem one more time. You can conclude that even with this information. It's a really nice feature of Excel Solver report. This is pretty much how you read the sensitivity report. Solver limits report, it basically tells you what happens in the worst case, in the best case. So these are the decision variable values at the optimal solution. The lower limit can be these for these decision variables, and then the upper limit can be these decision variables. Well, when those values are at their lower limits, these are the objective function values you can get, right? Basically, for the Deercrest models, those are not changing at all, but for the Jordan products, those are changing. It's always a question mark how Solver creates names in reports. You have to make your template efficiently. You have to create your template efficiently. So for this product, for this Excel file that we just produced, as you can see, so these are the names of our decision variables. So what Excel did is Excel picked up this keyword and then merged it with Jordanelle and Deercrest, and it named our decision variables. For the constraints, what it did is it picked up the fabrication word from the cell, and it merged it with our SUs, and then it named our constraints as well. So the way that you represent your keywords here in this model is going to impact how you obtain your names in the Excel file.